Okay, thanks for the introduction. So my talk is about acceleration of blockchains on SmartNIC. So maybe before I go into the slides, some word on SmartNICs. What is a SmartNIC? Smart Network Interface Card. So in contrast to a conventional network interface card, such cards have vast processing resources on the network interface card already, so that incoming packets can already be processed on the NIC, and thus the CPU can be offloaded with this. And there are two types, maybe classes of such NICs, either ones that are working software-based with a bunch of parallel software programmable processors, or also based on FPGAs, field programmable gate arrays. This is programmable hardware, and this is exactly what we are using for our investigations. Okay, now short overview. So I will look at general accelerator options in general, so not tailored yet to blockchains. Then I will address the question that when we apply such offloads, of course, it has to be a good hardware-software partitioning to say, okay, what is really done in hardware now on our hardware-based SmartNIC in hardware, and how the rest of the functionality is in software, and how this really cooperates well. And then I will have a short look at two such platforms that we are currently using, and then I will summarize. So the overall idea is actually that we say, okay, with our work we want to investigate how we can apply such SmartNICs in the domain of blockchain acceleration. So we are working in this area with other application domains where we already work on blockchains, on SmartNICs, sorry. And the question is now, can we transfer these ideas also to blockchain? And the naive view currently on the right, so don't take this too seriously, this is more a symbolic view, so that we say, okay, we have the compute system with a NIC and several processor cores, and on top the software stack operating system, in this case the Alogrand virtual machine, or then the TEAL on top. And the idea is to say, okay, can we now take some of these functionalities, they are colored here, out of the software, migrate it to a SmartNIC. You see now we are talking about here on a SmartNIC, and profit from that in terms of now the idea to increase performance, so that we get higher throughput of our node that works on blockchain, in the sense of maybe more transactions per time, or also lower latencies from that, or also very important nowadays to come to power dissipation reduction. And what we want to investigate in our research, apply this acceleration for Algorand specific functions. I will come in the next slide already that we identified message relaying and forwarding as a special function which is worth looking at in relay nodes, or even generic networking functions which have anyhow to be done, packet header parsing or modifications and the like, so to migrate this into these hardware-based SmartNICs. So first, generic options, how we can imagine to use such SmartNIC-based accelerations, so that we say we have our now a bit more elaborate system, so the host CPU and still our SmartNIC, and I now introduced a bit more how it looks inside. We have some ingress data paths, so when packets come in, so that we do some ingress processing on the packets that are arriving, and generate additional context or results that we then forward to the host CPU. Work on this, can use already this pre-processed data, and when sending out, maybe sends out some commands together with packets, which are then executed on the fly during sending the packets on the network, so that they are then manipulated, and that this manipulation is not anymore necessary to be done on the CPU, but on the hardware actually. So this is, you see, the CPU is still in the loop. Maybe in the extreme case, it could be even that we have the required functionality of certain packets or messages can be fully implemented with the ingress and egress processing paths, so that really they have a direct hardware-only data path from the ingress to the egress. So you can imagine latencies could be significantly improved, because you don't have to travel to the software stack and back again. Or third alternative, use an accelerator as a kind of accelerating function for a pipeline of processing steps that are done anyhow in the CPU, but maybe some complex things could be more efficiently done on hardware, so call an accelerator in between. So this is a bit less of interest in our case now. Still more closer look at this, because I said hardware software co-design, so we have to clearly distinguish what can be really migrated to such a hardware NIC with hardware processing capabilities, and what should stay on the CPU. So we say, okay, anyhow, it's necessary that traffic that comes in should be forwarded without being processed and transparently to the CPU of traffic that is not relevant for this type of application, and anyhow should be forwarded, and also outgoing packets should be unmodified, could be sent out. On the other hand, what we think is necessary to stay on the host is actually some kind of standard blockchain function, non-blockchain functions, as I said, complexer functions which are not so easy to be mapped on really specific hardware. So therefore, of course, this is something with many exceptions or something like this, so it's not good to capture this in hardware. And also what is important, because when we offload certain functionalities to the hardware, of course, this hardware has to be controlled by the software, so the hardware does not act by itself, but it needs information coming from the software. And so therefore, software or functionality that controls the hardware-based functionalities on the SmartNIC, they of course have to be executed as well on the CPU. So on the SmartNIC itself, I mentioned this ingress-egress processing. So and I also mentioned that this is controlled by software on the host CPU, so the hardware does not have an own life. It's only acts as authorized by the software. And this is actually symbolized here, that we say the software writes down some configuration information that is necessary for doing ingress or egress processing. Then we do here egress side processing on packet or frame or on message level, where we have to assemble several packets to build a message which is then processed. And of course, especially also when I'll talk about relaying, sending packets several times out, of course you have to have local memory to store the messages for being sent out several times. So you need local storage here as well. Now we looked at Alogrand especially, and we identified that the relay nodes would be good candidates for such an investigation to see how SmartNICs can then be employed favorably. And we identified actually the message relaying and forwarding as a major interesting functionality, and all associated compute-intensive functions that are necessary for that, for authentication or calculating hashes or whatever, so something like that is related to that as a candidate. And we know that actually in this case we have to relay 3 different types of messages, namely transactions, that proposed transactions, or then blocks, proposed blocks, and of course then also the voting, so that this has a variety of sizes, but as far as we know, up to 5 megabytes with the blocks. And then all packets that are actually making up a message, they would have to be sent to a set of relay or participating nodes according to the consensus protocol. And here we see symbolized, so we have our node with our SmartNIC, and one incoming message might have to be replicated to several outgoing targets. Now, I have made a bit more closer look, considering the functionalities that we think should be in software related to Alogrand. So this is the yellow case. We do it in software. So of course, doing everything to be part of the Alogrand network is something, of course, done still in software. Also, to establish connections to the peer relay nodes, something like this, we would expect that it's still done in the software side. Then also, when these connections are established, that we then, this is the important thing, could come now into play, that we give this information down to the hardware, so that we know, okay, on what transport protocol ports does our relay node listen, and also on the other hand, from which transport protocol ports should we send out then, of course, then these messages, and of course this has to be known here locally in the ingress and egress part. Or also what is very important that, when doing verification and authentication, of course we would have to know the keys in order to be able to do this locally on the hardware, and therefore we would assume that the software provides these things as well, and of course also the addresses, target addresses for the outgoing relay targets, of course. Whereas on the other side, now the hardware part, so what is always important, we have to know what packets are coming in, frames are coming in, have to classify, parse them, classify them, in order to know, okay, have they to be sent unmodified to the software, or is this now specific, something specific to our Alogrand functionalities we have to implement, and then do the appropriate processing. So this is a major thing, of course. Then we have to, when it's about such messages that have to be relayed, so we have to store them in local memory, and also we have assembled them from several packets in case of blocks, which are of course bigger than one Ethernet frame. Verify them, authenticate them, with these keys, so that we know, okay, these are really authenticated messages that are relevant and should not simply be discarded. And of course, also what is important, what we learned, that obviously in the Alogrand network there could be the situation that actually messages arrived several times at the same node, and that there has to be the way to detect this, to check, okay, this message has already been forwarded from my current node, have to detect this and then discard this second or further copies. And therefore, we would assume to have hash calculations, store these hashes, go through them, search them. So this is also something which would be of relevance. And of course, then send these copies of the messages and the associated packets that are actually making up the message then to these recipients. So this is a very rough overview in the moment. What we think about could be put to the SmartNIC, what has to stay on the host, and see how to play, that these things play together. And this is, from our perspective, one of the most important challenges to extract certain functionalities out of the implementation that is available, software implementation that is available, and make this runnable, so that it really works. And this is a big challenge. So now I want to have a look at two platforms that we are using at our chair as SmartNIC, FPGA-based SmartNICs. As I said, we are not looking at these other types of SmartNIC, and they are both based on Xilinx FPGAs. This is Vertex 7, a bit older one, has limited support for interfacing with the host, and we are now on the way to migrate to these very performing with high interface speeds Alveo cards. But I don't dig into detail, so these are these beasts that are to be programmed and connected to the host and with the software. This brings me already to the summary, so maybe I'm the one who does not exploit his time so much. So what we say, okay, SmartNIC could be a potential blockchain accelerator, so it has to be shown that it really applies, but we are confident from the concept ideas. That we identify the message relaying for Alogrand as an approach, and we did and are still doing in-depth analysis of these relaying functions in the software implementation, which is tedious, a really difficult thing, because it's not very well documented, and to see how things are really implemented, and in order to know how then to extract certain parts out of this functionality, put this on hardware and make the interplay working. This is really the biggest challenge. So therefore we are on the way to say, okay, how can we clearly specify the hardware-software interface? Then, of course, how to implement these functions that are relevant in the way that it complies to the things that are expected from the software side, of course, so that it interoperable with other nodes, of course. And we have already As I said, we are working on SmartNICs already in different domains, have a hardware-based data path already, which does parsing, and also we are doing load balancing things and so on, that we adapt this to our use case here. And of course, and this is for everybody who works with FPGAs, a thing that is not so easy to have it simulation-wise running, and then really working on the hardware is still a big step. So these are things that are still also to be considered. And with this, I'm already at the end of my talk. Thanks.